Okay, good evening. Can you hear me? Okay. Good evening, and this
Good
is
evening,
the
sir.
okay. This is the fourth session of our first lesson, measuring instrument. Last week we discussed vernier caliper, completely discussed. What we discussed up to now. Okay, first of all, today a lot of new students. Therefore, I will explain what we doing and what we did up to now. Okay, I will explain about our plan and our future schedules. Okay, first of all, we have 25 lessons. Okay, we have 25 lessons. I will send the lesson list and lesson classification. I will send it to group today. You have 25 lessons. These 25 lessons, we can classify it into five categories. In science for technology, in first introduction session, I explained in science for technology, we are discussing basic scientific concepts that is important to understand technological approaches. To understand technological things, technological applications, we are discussing basic concept, basic principles actually. Okay, these basic principles we discussing under five areas. Under five areas. What are the areas? Physics. Physics is the main part and bulk part because a lot of technological approaches based on physics. That's why. That's the reason. Our second lesson, second part, chemistry. Our third part, biology. Fourth part, mathematics. Final part, ICT. Okay, this 25 lessons we can say 8 physics lessons, 6 chemistry lessons, 2 biology lessons, and 5 maths lessons and 5 ICT lessons. Sorry, give me a second. Now everything okay, right? Shivan, I think something
Yes, sir.
happened. I think now okay.
Yeah.
Okay. Yeah, we have 5 math lessons and 5 ICT lessons. In biology part, we have a very small section. We have only two lessons. Okay. What we doing now? We doing physics part now. We not going to discuss full physics part and start chemistry part. This is not the method. First, we have to make the foundation first. Okay. In physics part, today this first initially we discussing the foundation basic lessons. Our first physics basic lesson is a measuring instrument, because without measurements we can't understand any other physics lesson. We can't understand or learn any other physics. We can't discuss any other physics lessons. Okay, that's why we discussing about measuring instrument. In mathematics parts, our first lesson is area and volume. Area and volume is basic. In ICT parts, in as basic fundamental, we discussing about input and output devices and computer systems like this. In biology part, we have a very small part. It's a very small, but these lessons are a little bit bulk. It's full theory lessons. In chemistry part, as initially we discussing thermochemistry for develop our basic knowledge. Okay. 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 Today, last week, not actually last week, before 3 weeks ago, we start measuring instrument lesson. This is our first physics lesson. Measuring instruments. In measuring instrument lesson, I told we are discussing 3 type of measuring instrument. Do you remember? 3 type of measuring instrument. Measuring instrument. Measuring instrument lesson, I told we discussed three main types of instrument types. What are the types? Length measuring instrument, mass measuring instrument, and time measuring instrument, right? Do you remember? Okay, what are the length measuring instrument? What are the length measuring instrument? Yes, first one meter ruler. What else? Meter ruler. What else? Jansilu? Last week you completed one? Very good. Vernier caliper. Vernier caliper. Third one. Ruksha.
Micrometer screw gauge.
Micrometer screw gauge. This is our today lesson. Very good. Micrometer screw gauge. Micrometer screw gauge. Micrometer screw gauge. Final one, traveling microscope. Our next week lesson. Traveling microscope. Traveling microscope. Traveling microscope. Okay. I will explain. Mass measuring instrument. What are the mass measuring instrument? Electronic balance and triple beam balance. Electronic balance and triple beam balance. What are the time measuring instruments? Mainly, what are the time measuring instruments? Stopwatch. Very good. Stopwatch. Stopwatch, different two types: analog stopwatch and digital stopwatch. Okay. If we discussed all these measuring instruments, same as vernier caliper. If you can remember, last week we discussed what are the parts of vernier caliper and what are the functions of each parts and how to read measurements using vernier caliper, how to calculate the least count of vernier caliper, and how to identify errors of vernier caliper. Everything we discussed with all practicals. Is it up to now? Are you complete? New students, I will give you recordings. Last 3 weeks recordings, and you can continue. You can complete this previous parts by recordings and continue from today lesson. Okay. New students, no any doubt. Today we are going to start very new instrument. Our third length measuring instrument, micrometer screw gauge. Micrometer screw gauge. Okay. Before that, we have a celebration actually. In 2025 result. 2000, now you already know I have sent it to your group. 2025 A-level result. We got in English medium all island students, we got first place, all island. The result for science for technology A, actually it is not A, it's A plus actually. For SFT, he got 48 MCQ marks. 48, you know, in first paper you have 50 MCQ questions. He got 48. Only 2 mistakes. 48 MCQ questions. MCQ correct marks. And second part also he have done very well. Then definitely SFT marks more than 90. More than 90 SFT marks. For ICT, he has A pass, and unfortunately for ET, it's a B. The Z value, 2.6696 is the Z value. In Colombo district, 16. In all island can mediums තුනෙන්ම ගත්තා. Mediums, Tamil medium, Sinhala medium and English medium, all medium. He got a merit rank, but it is not enough actually. This is the best result in all island, English medium students. But in all mediums, it is island rank 78. That's a unhappy story actually. The best result, our English medium students' best result, we can happy he's the students was in our class, but the problem, he has merit rank. We can happy, but he all island it is 78. 78. It's not a good thing. Okay, now 2026, 2027, 2028, your batch. Somehow we have to get first island 10 rank එකක්වත් ගන්න ඕන. Within first 10, we can achieve this definitely. 2026, 2027 with. Okay, when I start classes 2023, there was no any SFT English medium A passes. All island. My first batch 2024. පළවෙනි batch එකේ 2024. Yes. 2024 I got, not I actually, our students got 2A passes with 2024 best island rank with best island result, best result in island for English medium students 2024. This time also best result in our class 2025, best English medium result, but unhappy thing is the island rank 78. 78. Okay, therefore you have now you have a responsibility to get it into within 10 first island 10. First 10 එකටවත් අපි යන්න ඕන. හරි. No need to worry. 2028 also the best English medium result in our class. No any doubt, no any worries. But the thing is, the best result we have to achieve at least within first island 10 ranks. That's a target. That's a challenge actually. Best result අපේ තමා, but the problem මෙතනට ගන්න එකයි වැඩි. We have to work more, right? We have to compete with Sinhala and Tamil medium students. The thing is, they have a lot of resource books and they have a lot of term tests and additional papers. That's the actual issue. Okay, now 25 students, I did my maximum for SFT. I given all papers I translated into English, and I given all type of papers, model papers, past papers, term test papers and provincial papers, everything I translated. In education department not release English medium papers. They only given Sinhala and Tamil medium. For English medium අපි translate කරන්න ඕනේ. I have translate. Okay, for 2025 students, all type of papers I translated and I given. That's how we got more than 90 marks for SFT. More than 90 marks. Okay, it is not a easy thing. I'll show you the difference. If you got more than 90 marks for any subject, that's the difference. This is the all best information ICT A, engineering technology B, science for technology A. Okay, what is island rank? Is it 2.6696? It's a good Z value. It's a competitive Z value. We can compete with other medium. But I'll show you another result with same grade. Another result in same grade. See, ICT A, engineering technology B, science for technology A. Same result. Same result. But compare Z value. Oh, sorry. See the Z value. Z value. It's a Sinhala medium student. 2.173. 1723. It's a huge difference. 2.66 and 2.17. approximate 0.5 difference. What's the reason? What's the reason? Miyagi AAB 75 again very close to 75, 75, 75, B very close to 65. That's the difference. But our student, he has score for SFT, definitely he got more than 90. More than 90 he got. Okay, that's the reason. If you got normally in A level or whatever, O level and A levels, it's not coming A plus results. Neither. If you got more than think for SFT, ET and ICT, or ET or BST, think if you got 76 for SFT, for ET if you got 70, and for ICT if you got 78 type marks, how about your result? AAB, you have 2 A passes and 1 B. Okay, this type result, how about this value? 2.1 value. But if you score same result with same result, if you got 90, less than if you got 73, ICT again 85 type marks, definitely your Z value, if you got more than 75 for any subject, it is bonus actually for your Z value. Not like O level. In O level exam, if you got more than 75, it's useless. You can get only A grade. But in A level, it is not like that. If you got more than 75, it is bonus. Could you understand? Now, it is 2.66. It's a huge difference. In Z value, I think still you don't have much knowledge about Z value. 2.1 and 2.6, it's a huge difference, but same result. AAB. Same result, Z value, huge difference. Therefore, if you got 75 marks, can you compete with other medium students? No. You have to achieve more than 75 marks. Due to this is the most competitive exam in the whole island. Therefore, you have to more focus and manage your works and schedule your works and consistently continue works. That's very important if you need good result, good rank, good result value for the exam. Consistently working. Every day, particular time, you have to separate for your academic things. Do you have any doubt about this our result or whatever thing? Do you have anything? Okay, let's move into lesson. Okay. Now last week, we discussed and completed the vernier caliper lesson, right? The vernier caliper. Okay, this is the vernier caliper, all practicals and theory all completed. Okay, today we are going to start our second instrument, line measuring instrument, micrometer screw gauge. Micrometer screw gauge. Okay, this is the micrometer screw gauge. Do you have seen this before? And anyone used this instrument before? Okay, this is very small instrument, no? Not like vernier caliper. This is the instrument. This is the instrument. Do you have seen before? Rukshana? Vihanga? දැකලා තියෙනවද?
Sir.
No. Others? Yansilu? It's very new instrument for you. Okay. Then I will explain. I will start very basic level and explain one by one point. One by one point. No worries, no worries. දන්නේ නැති නිසා ඉගෙන ගන්න ඕනේ. හරි. අපි කරමු. හරි. Then I will explain point by point of about this instrument. This is very important. Normally, vernier caliper. Do you remember vernier caliper least count? Least count means the minimum reading. The minimum reading that can we get accurately. That's the least count. Do you remember? Normally, vernier caliper 0.1 millimeter, right? 0.1 millimeter of the least count of vernier caliper. This micrometer screw gauge we can use to measure 0.01 up to 0.01 millimeter least count. That's the least count. Then using vernier caliper, we can divide 1 millimeter into 10 parts. 1 divided by 10, it is 0.1. But using micrometer screw gauge, 1 millimeter, we can divide into 100 segments. Sorry, 100 segments. That's why it is 0.01 millimeter. Okay, therefore, the micrometer screw gauge more sensitive than vernier caliper. More sensitive than vernier caliper. Hard. Okay, please open your tute. Before that, please raise hand if anyone don't have a tute. Are the tutes new students? Senura. Okay, wait. I have not down. Only 5. They all have tutes, right? Okay, Senon, then you can collect it tomorrow. Then you have tutes. 1, 2, 3, 4, 5, 6. 6. Rukshana, 7. Okay, after class, can you send me WhatsApp message? I don't have tute skill. Then I will add into a system and you will have tutes within 3 days. In 3 to 4 days, you will have tute. Okay, I'll collect all details at the end of the class. Okay. For now, I will send you the PDF file. Is it okay? For today class, I will send you PDF file. Wait. Okay, now you can download the tute in your chat. Okay, so you have soft copy now. Okay. Printed tute I will send you as soon as possible. Mama ගිය සතියේ ගොඩක් කැවුවා tutes. 7 or 8 packs I already posted. එතකොට මේ සතියේ join වෙච්ච අයට තමයි නැත්තේ. Okay, no issue. Okay, now you can download the soft copy. Only this week you have to manage with your soft copy. Before next week, I will give you all printed this tube. Okay, this is your tube. You have all parts perfectly separated in the tube. Okay, you can get before next week. You can get this tube. Okay, let's start. Our second length measuring instrument, micrometer screw gauge. Go to in the tube page number 9. Go to page number 9. Go to page number 9. Okay, do you remember what the meter? What is the least count of the meter ruler? What's the least count of the meter ruler? That was 1 millimeter, right?
1 millimeter.
Yeah. Vernier caliper 0.1 millimeter. Actually, the micrometer target, micrometer screw gauge purpose to get measurement less than vernier caliper, more sensitive than vernier caliper. Okay, that's the main purpose. Okay, do you remember in vernier caliper, what's the principle of vernier caliper? That's the most important part. Please understand. Mebala, do you remember in vernier caliper, what's the main principle? What's the main principle of vernier caliper? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it is same as your ruler. And I told it is continue up to 150 millimeter. And what is the name of this? It is the main scale. This is a main scale. Main scale. Main scale. Hurry. This is a main scale. This is a main scale. It is same as your ruler. And do you remember the vernier scale is a movable scale? The vernier scale is a movable scale. Movable scale. Some particular parts on the main scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some particular parts on main scale divide into identical parts using vernier scale. That is the main principle. That's the main principle. Do you remember I told the common vernier caliper 9 millimeter on the main scale divided into 10 identical parts. Divided into 10 identical parts. 9 millimeter on the main scale divided into 10 identical parts. This is the main principle of the vernier caliper. Okay, what is the name of the second scale? That is vernier scale. Vernier scale. Okay. Now, if you got only main scale, what is the least count? Without vernier scale, if you got only main scale, what is the least count? Yansilu? Without vernier scale, if you only consider main scale, what is the least count? It is only 1 millimeter, right? To get less than 1 millimeter measurement, what they have done? They have got another scale, another linear scale. අපි 1 millimeter වඩා least value එකක් ගන්න, අඩු value එකක් ගන්න. They have used another scale, but the thing in main vernier caliper, main scale and vernier scale both linear. No any circular scales. But in micrometer screw gauge, please understand this first point. Only first point is difficult. Other parts are simple. මෙතන චුට්ටක් අමාරුයි තේරුම් ගන්න. Try to understand your best. Focus very well. After this point, you can easily understand about this instrument. Okay, it is actually very simple. Only this point you have to understand this principle. In what I told, in vernier caliper, if you only got main scale, it is same as your ruler. its least count 1 millimeter. To get less than 1 millimeter reading, they have used in vernier caliper has another scale, another linear scale that named as vernier scale. Hurry up to now, okay? Up to now, okay? Okay. In micrometer screw gauge, the same principle in micrometer screw gauge. In micrometer screw gauge, the same principle, but the difference is in micrometer screw gauge there is there is a circular scale as well. That's the main difference. Okay, in micrometer screw gauge there is a linear scale like this: 0, 1, 2, 3, 4, 5, 0.5, 0.5. Think this is a linear scale. Some amount of particles on linear scale. This is a linear scale. This is a linear scale. That's the basic principle. Linear scale. Linear scale. Linear scale. This is a linear scale. Some amount of parts on linear scale divided into identical parts using a circular scale. That's the main difference. Okay, I will explain again one by one. Please understand the difference between main vernier scale and vernier caliper and micrometer screw gauge. This is a 0, 0, 1, 2, 3, 4, 5. Sorry, 5. 5. Then 45. Okay, that's the main difference. That's the main difference. That's the main difference. In vernier caliper, some amount of parts on main scale divided into identical parts using another linear scale. Our linear scale use but in micrometer screw gauge, some amount of parts on the linear scale divided into identical parts using another circular scale. See, circular scale. Can you see this? Make it fair now. Okay, this is the instrument. This is the instrument. Fair. This is the instrument. This is the instrument. This is a linear scale. This is a linear scale and this is a circular scale. Circular scale. I will show you a virtual one. Actually, this instrument is very small one. Okay, I will show you a virtual one. Hurry. Okay. Can you see this? Can you see this? Okay. Now, can you see that's the basic principle? First, understand the basic principle. Understand the basic principles. Okay. This is the linear scale. Linear scale. And some amount of particular parts on linear scale divided into identical parts using second scale is a circular scale. That's the basic difference. That's the thing you need to understand. First point. First point, in vernier caliper, our previous instrument, some amount of particular parts divided into identical parts using linear scale, secondary linear scale. That's a vernier scale, right? But in micrometer screw gauge, some amount of particular parts on the main linear scale divided into identical parts using a secondary circular scale. Understood? Circular scale. That's only you need to understand. First point. Done? Send message. Done, right? Done, right? Yeah. In vernier scale, secondary scale is another linear scale. Therefore, main scale and vernier scale both linear scale. But the difference in micrometer screw gauge, it has a linear scale as well as it has the secondary scale. What? It's a circular scale. That's only difference. First point is done. It is very simple. Done. Okay, now let's try to understand parts of the micrometer screw gauge. Then it is very easy to understand this instrument. Okay, these additional parts you can understand after discuss parts. Okay, they are the parts of the micrometer screw gauge. They are the parts of the micrometer screw gauge. They are the parts of the micrometer screw gauge. Okay, this is the instrument. This is the instrument. Okay, the first part. Can you see, before that, can you see this type U shape curve that we called as a frame? That is a part, all parts of the micrometer screw gauge attached to this U frame that we called as U frame. All parts of the screw gauge attached to this U frame. Actually, this is, see, all parts connected to this U frame. Okay, what's the name? It is frame or U frame, both correct. Frame or U frame. Okay, then what is the name of this part? Can you see this? This part. That part we called as anvil. Anvil. A-N-V-I-L. Anvil. This is a part. It is a fixed part. We can't move this. It's a fixed part. This is anvil. Okay. There is another rod in opposite side. What is the name of that? Spindle. S-P-I-N-D-L-E. Spindle. Please highlight. Or if you don't have tilt, you can note down. You can note down as a short note. Then you can, once you tilt received, you can highlight it. Okay, now I told 3 parts. Kian, what's the name of that?
U-frame.
U-frame. What's the name of this is fixed part? Fixed small rod? This one.
Anvil.
Good. This one?
Spindle.
Now understand, when I rotate this circular scale, what happened to the anvil? Sorry, spindle. Anvil is a fixed part. What happened to the spindle? It is moving, right? It's a movable. Can you understand? When you rotate by circular scale, it is moving. It's moving, right? It's moving. Okay, I will show it very clearly. That's very important. Okay, remember now three parts I explained. 3 parts done. Okay, now what is this? This is the U frame, and this stationary fixed part is the anvil, and this moving part. Please understand this moving pattern. If I rotate this circular scale into tight direction, now it is tightening, right? Now it is tightening. tight venom. Tightening, and what happened to the spindle? Spindle move towards the anvil, right? Spindle move towards the anvil. Okay. Now, if I rotate into opposite direction, what happened? The screw is releasing. The spindle move away from the anvil. I got spindle move away from the anvil. I got understood. Done. Okay. Second point. Okay. Hari, 2 points done. Hari, pit done. Okay. Understood. Terna. Okay, maybe if I rotate into this, it's moving towards the anvil. If I rotate to opposite direction, it's going away from the anvil. Going away from the anvil. Okay. Now again revise. What is this? U frame. U frame. What is this fixed rod? Anvil. This moving rod. It is spindle. Hurry. Now please change into the for is main scale also correct, but for easy understand we can change into linear scale. Linear scale. Linear scale. Linear scale. Linear scale. Change it to linear scale for easy understand. Both correct. But if you use main scale, it is it's difficult to manage with vernier caliper. No, vernier caliper also main scale. Okay, therefore better to use as linear scale. Linear scale. Hurry. Done. Okay, now this is the linear scale. This is a linear scale. This is a linear scale. This is a linear scale. Okay. Now understand the linear scale. And this rotating one is the rotating scale is the circular scale. Circular scale, this one. This the rotating one. Make it clear now. I will show you by virtual one. Okay, this is a linear scale. This is a linear scale. This is a linear scale, and this is a circular scale, the rotating one. Hurry. Now you know 5 parts. Okay, tell me parts. This one, U frame. This one, anvil. This one, spindle. What is the name? The part where it's located cursor.
Sleeve.
Yeah, sleeve or linear scale, right? Sleeve mean actually this metal rod. This metal rod is a sleeve. I got. Can you see this? The linear scale is calibrated on the metal rod, actually cylindrical rod, right? Cylindrical rod. This one. This is a sleeve. That's iron sleeve. Iron sleeve. And please, and this is the linear scale. Done. And what is the name of this rotating one? It is 5 parts done. 5 parts done. Up to now, okay. Now, now, what is the name of this part? That is a part we can rotate this. No, it has a rough surface. It has a rough surface to rotate this, rotate and fix this to measuring while measuring objects. To rotate this circular scale, we use this part. What's the name that we called as a thimble? Thimble. 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 And final part is the thimble head or ratchet. Thimble head or ratchet. Ratchet. Both correct. Ratchet. Thimble head or ratchet. 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 Thimble head or 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 ratchet. Hurry. Then key more parts. What is the name of this? This rough surface?
Timber.
Thimble. Very good. Very good. The final one?
Timberhead.
Timberhead.
Thimble head or ratchet. Very good. This one?
Anvil.
Anvil.
Anvil. Very good. This one?
Spindle.
Splint.
Spindle. Very good. This one?
Linear scale.
Yeah, linear scale or linear scale includes sleeve. Sleeve. Iron sleeve or iron cylinder. This one?
Circular scale.
Circular scale. Very good. Okay, they are the main parts of the micrometer screw gauge, and there is another mechanism. Can you see there is another lever here? What's the purpose of that? Using this lever, now this is the unlocking stage. Unlock stage. This is the unlock stage. Then we can rotate this. We can rotate. But if we fix this, if we lock this, again we can't all rotating, all moving material, all moving parts of the instrument will be locked using this lever. Therefore this lever we called as a locking lever. Okay, they are the main and all parts of the micrometer screw gauge. Do you remember all parts? Because without these parts we can't continue this lesson. Happy. Let's try one more time. This one?
Anvil.
Anvil. Spindle. This one?
Locking lever.
Locking lever. This one?
Sleeve or linear scale.
Sleeve or linear scale. Very good. This one?
Circular calc.
Circular scale. Yes. Final point. Final part.
Head or ratchet.
Ratchet. This one?
Timber.
Timber. Very good. Everyone remember? Any doubt up to now? Please ask me. Any doubt up to now? Hurry. Great. Hurry. Now, I will show you how to get any measurement using my micrometer screw gauge. And I will show you what are the advantage of using this micrometer screw gauge in practical. Then we can discuss theory parts and easily you can understand. Hurry. Easily you can understand. Actually, this lesson might be full measurement lesson, not only measurement lesson, lot of physics lessons are practical lessons. Up maybe that okkoma karana. We doing all practicals and discuss theory parts in the same time, at the same time. Therefore, actually physics part, you don't have anything to by heart. Now, today, everything now you can remember, right? Same as future lessons also, we doing in practical way, then it is very easy to in exam, and I will discuss all past paper and model paper exam questions after this lesson. Then you can easily ready for the exam. Okay. Hi. Okay, I'll show you how to get any measurement using micrometer screw gauge. Oh, give me a second. I want to connect my charge. Okay, sorry. Okay, okay. Now I will show you how to get reading, how to get any reading using any measurement using this micrometer screw gauge. Hi, ಮೊದಲು ಬಲ. Hi. Okay, I will take an object, right? Hi. Okay, I want to get the diameter of this clip. I want to get the diameter of this clip. Hi. Now, ಮೊದಲು බලන්න. First step, I need to place the object between anvil and spindle. Place the object between anvil and spindle. Place the object between anvil and spindle. And I can start rotating by thimble. Start rotating by thimble. Start rotating by thimble. While rotating, you can see the spindle come towards the anvil, right? Spindle come towards the anvil. Spindle come towards the anvil. Spindle come towards the anvil. Now it is very close to the clip, right? The spindle very close to the clip. Now we have to stop rotation by thimble. They are the steps. Now we have to stop rotation by thimble. You have to only rotate by thimble head or ratchet. I'll explain the reason. Wait. Can you see any sound? Can you hear any sound? Sadhya cannot. Yes or no? Can you hear Any count? This is the sign. This is the sign. What is the meaning? If it is coming this sound, that's meaning the spindle and between spindle and anvil, the object have tight in required tightness. Required tightness. See, this is a required tightness. This is a required tightness. Me again not fall. This is a required tightness. This is a required tightness. But if I additionally rotate by thimble, what happen? It's don't have any measurement. Me I can move. I can tight more. This over tightening. You can see the shape of the clip is changing. It's additional pressure. Do you remember in the first day of the lesson, I told we can't apply additional pressure on the object. We can't apply additional pressure. Me, then I'll pay another. It has changed the shape. It's deformed. Deformed. It has deformed. See, if we tied by thimble, only thimble, it's deforming. We don't have any measurement about tightness. We don't have any measurement. Now you can see it has deformed. Deformed vela thin, tight vela thin, over tight. Over tight. Okay, that's why that's the actual purpose of thimble head or ratchet. We can tight the object between anvil and spindle with required tightness, correct tightness. Okay, I'll show you again. Okay, you can get the object and place close to the anvil. You can rotate by thimble until spindle reach close to the object. Close to the object. Now it is close. Now only rotate by thimble head. Now you can see this type sound and it's freely rotating. If we rotate many times this thimble head, again no any changes in about other parts, remain parts. It's only freely rotating. Thimble head freely rotating. I got? Okay, they are the steps. Measure using micrometer screw gauge. Understood? Clear? Tiruna? Okay. Give me 30 seconds. Please revise again. What are the steps? Okay. Okay, sorry. Hi. Okay, they are the main parts of the micrometer screw gauge, and that's the method using this mic to how to get reading or measurement using micrometer screw gauge. Okay, I will show you again what are the steps. These steps very important. Place the object close to the anvil and tight thimble until reach spindle close to the object. Close to the object. Close to the object. When it is reached close to the object, right, turn only by thimble head or ratchet until coming this down. Okay, then using linear scale and circular scale positions, we can calculate the reading. We can read the measurement. We can read the measurement using same as vernier caliper. Understood? Hari? Clear now, right? Okay, great. Now, function of each part. Okay, let's see. Frame. It's a C-shaped body of the micrometer screw gauge. Yes, the body frame is a C-shaped body or U-shape. මෙහෙම ගත්තොත් C නේ. Okay. C-shaped body. It's hold all part of the instrument together. Okay, please highlight. It's hold all parts of the micrometer screw gauge together. That's a part. Hold all parts. You can see the anvil is connected to this U frame, the spindle connected to U frame, and all circular scale, linear scale, all parts connected to this U frame. Okay, I'll show you. Wait. Okay, if I release these parts, see, this is a U frame, and the anvil connected to this U frame. Linear scale includes sleeve connected to U frame, and the circular scale and spindle separate part connected to this sleeve. Then all parts hold at the U frame, right? U frame. Clear? Anvil. Anvil. Anvil is a fixed measuring surface attached to the frame. Yes, it is fixed. It's fixed. I already explained. Hold one side of the object being measured. Yes, the anvil hold one side of the object, right? Good. Highlight. This is a function. Okay, spindle, the movable measuring surface. Yeah, it is movable. It is movable. It is moving with circular scale. It's a movable measuring surface that's more towards or away from the anvil. Yes, that's moving towards or away from the anvil that we discussed. Towards or away from the anvil. What's the function? What's the function of spindle? Hold the other side of the object and help the help to measure thickness or diameter. Hari, තේරෙනවනේ? The spindle. The sleeve or linear scale. Sleeve mean this cylinder, iron cylinder. The stationary cylindrical part marked on the linear scale. What is the function? To get the linear scale reading. That's a function. To get the linear scale reading. Okay, next one, thimble. What is the purpose? Thimble is a rotating cylindrical part attached to the spindle. Yes. Yeah, it's correct, right? I told you. I showed. The thimble is a rotational cylindrical part attached to the spindle. See, this is a spindle. It attached to the spindle. Done? Understood? It's attached to the spindle. Attached to the spindle. Contains one circular scale. Contains circular scale divisions. Yes, the thimble contains circular scale divisions. Correct. Measure the circular scale parts. I'll explain measuring methods later. Okay, ratchet. Okay, that's the most important instrument, most important part of the instrument. Okay, what's the purpose of the ratchet? What's the purpose of the ratchet? What's the purpose of ratchet or thimble head? Ratchet or thimble head? Ratchet or thimble head?
Ensures contrast measuring pressure by preventing excessive turning in.
Yes, very good, Shiva. Prevent excessive pressure or over tightening. Prevent over tightening and ensure correct tightness on the measuring object. Method. Ensure constant measuring pressure by prevent excessive tightness on the object. Are you good? If you have any doubt, please ask me. In very basic level, I am explaining. Hari, up to now? Understood? Rukshan?
Yes.
Yes, now, the locking lever, final part. Locking lever. Now you already know. What's the purpose? A small screw or lever connected to the frame. And what is the function? Lock the spindle position and keep the measurements fixed. Actually, this is a purpose. Okay, I want to see. Wait. Okay. I want to get the thickness of this pencil. Okay. Then I can place the object between anvil and spindle and tied by timber. Tied by timber. Rotate by timber. When spindle reach close to the pencil, reach close to the object, what I can do? I stop rotating by thimble and start rotating by thimble head or ratchet. When it is tight into required tightness, it is freely rotate with sound. It's freely rotate with this sound. Okay, then that's a measurement. That's a required tightness. Okay, if you want, you can tie this object like this and you can take out pencil. Again, no any changes. That's the actual purpose. Understood? Okay, this is the actual measurement of the actual thickness of the pencil. We can read by linear scale and circular scale. Clear? Clear, right? Hi. Okay, now we are going to most important part of the lesson. Before that, please note down, please read this two sentence. The same thing we explained given here. The purpose of thimble head. Kiyala bala. හරි. Okay, read this. The micrometer screw gauge is shown above with its main parts labeled. The anvil is attached to the end of the frame. Yeah, that's correct, right? Anvil is attached to the end of the frame. හරි, අපි මේක බලන්න කියමු. Anvil attached to the end of the frame. Yes, anvil attached to end of the frame, which is connected to a nut. Yes, the spindle. Yeah, it is connected to a nut. Yes, it has a nut. The spindle is connected to a screw. The spindle is connected to a screw with fine threads passing through a nut. Yes, it's actually connected to a screw. See, I will show you. Instrument micrometer screw gauge. Understood? That's why we call it is screw gauge. See, it has a threads. Can you see? See, it has threads and screw. That's why we call micrometer screw gauge. Actually, it's working according to the screw gauge principle. Screw principle. Screw එකක් rotate වෙන විදිහට තමයි tight වෙන්නේ. Understood? හරි. The main or linear scale is calibrated on a sleeve and the nut. Yes, it's calibrated sleeve. This is a scale. Okay, each point very important. That's why point by point I explain. And the screw can move along the sleeve. That's very important. The screw can move along the sleeve. That's very important. Hari, the screw can move along the sleeve. That's very important. See, screw can move along the sleeve. What is the meaning of that? When I rotate by this circular scale, what happens? It is rotating and circular scale move along the sleeve, right? It is moving with spindle. With spindle, circular scale also moving. Clear? If I rotate into opposite direction, it's moving to opposite direction. Clear? Clear now? If we rotate into tightening direction, that means right side, upward direction, what happened? It is tightening, and circular scale moving, circular scale or screw moving along the linear scale towards to the anvil. Done? Clear? It's moving towards to the anvil. If you rotate to opposite direction, what happened? It's releasing and moving away from the anvil. Away from the anvil. Okay. Up to now, any doubt? Any doubt up to now? Alright, good. No doubt. Anyone? Asandu? No doubt, right? Sweta? Nitira? Hard. Let's see next points. Hard. Very good. Okay. What's the point we discussed? The linear scale calibrated on the sleeve attached to a nut, and the screw means circular scale that we can move along the linear scale. While rotating, it's moving along the sleeve. Circular scale moving along the sleeve. That's very important point. The thimble head is connected to the screw. Yes. By rotating the thimble head, that means ratchet, final part, ratchet. The spindle can be moved along the main scale. Yeah, The spindle can move the spindle can move along the main scale. Yes. At the end of the thimble, there is a circular scale. Yes. While rotating the thimble head, that's the most important part. When the spindle just touch the anvil, yeah, while rotating the thimble head, when the spindle just touch the anvil, or when the spindle and anvil just touch an object placed between them, when they touch with spindle, the thimble head rotate freely and emit sound in mechanism due to a mechanism inside this. Okay, it's coming sound. Now I already explained. This is a theory. Now you already know the practical understand. Okay, now you already have practical understand. This prevents excessive pressure or excessive tightness apply on the object during measurements. Okay, up to now everything okay. Okay, now we move into the most important part. I'm going to explain how to get readings and measurements, how to read measurement using micrometer screw gauge. Okay, before that, please send me if you have any doubt up to now, up to this point. If you have any doubt, because next part very important. If you understand, if you need to understand next part, the previous part, you should have 100% practical and theoretical idea. No doubt. Okay, our first topic, linear scale. Okay, now you already know what is the meaning of linear scale, but we have to discuss in deep what is the meaning of the linear scale and what are the calibration methods and how about readings and everything. I will explain now. The linear scale is set on iron sleeve or iron cylinder, right? Iron cylinder. It has calibrated on an iron cylinder. That we discussed. It's calibrated 0.5 millimeter increments. This is important point. Providing the main scale reading of the measurement. Okay, think this is the sleeve, iron sleeve. That means iron cylinder, and iron cylinder. Remember, this is the linear scale middle axis. Linear scale middle axis. It has a horizontal axis. That's the middle axis of the linear scale. Middle axis. Okay, see this. Okay, this is the 0. This is the 0. This is a linear scale 0. And this is 1. Very important. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. This is a 10. And it is continue. This is a iron sleeve and linear scale. It is continue. It is calibrated on iron sleeve and it's continue up to 25 millimeters. 25 millimeters mean actually 2.5 centimeters. 2.5 centimeters. That is a linear scale. But can you see in linear scale or another important thing? You see another important thing. This is a linear scale, right? This is a linear scale. This one. This is a linear scale. Linear scale. And can you see? Okay, this is a linear scale. Now, can you see some lower side particles? What are them? What's the purpose of them? Okay, this is a linear middle axis. That means horizontal axis. This is a middle axis or horizontal axis, and they are the millimeter values. Then what are the lower side values? යටට තියෙන්නේ මොනවද? Okay, that's a they are the parts. මේ බලන්න, very important. See this? Okay, that is a 0. Remember, this is 0.5 millimeter. 1, 1.5 millimeter. 2, 2.5 millimeter. 3, 3.5 millimeter. 4, 4.5 millimeter. 5, 5.5 millimeter. 6.5, 7.5, 8.5, 9.5, 10. 10.5, 11. Okay, that is the calibration on the scale calibration on the iron sleeve in linear scale. I got. Then how to read linear scale values? 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. And continue up to 25 millimeters. Okay, that's why I told in linear scale, the value is calibrated 0.5 millimeter. The gap between two values 0.5. The gap between mean this is a gap. This gap 0.5 millimeter. Understood? Others understood? Very good.
Yes.
Okay, that is a calibration on linear scale. Yansilu, send me all. Sanura, oh Senura, Senura, Senura. Kalidu, Sandu. Hari. Everyone okay, right? Very simple. If you have any doubt, don't hesitate. Ask me. That's why I in online classes, අපි physical class වල මම මෙහෙම අහන්නේ point by point understood කියලා. But in online class, if you missed any part, it is very difficult to understand next part. Okay, that's why I again ask. If you have any doubt, you have to inform me. I will explain many times until you understand. No worries. Okay, please ask me if you couldn't get any point. Okay, please draw this and clearly draw these readings 0, 0.5, 1, 1.5, and values given 5 by 5. May want nam kala tiyenne 5 by 5, 0, 5, 0, 5 like this. Okay, see the actual value, actual one. It's calibrated 5 by 5. 0.5 parts given and 5 by 5. 0, 0.5, 1, I believe 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10, 10. Then it is 10.5, 11, continue up to 25 millimeter. Remember, linear scale maximum value 25 millimeter. Done? Hi. Please draw this. Draw this. Okay, complete. Sorry, there was a connection issue. Now, okay. 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 Now circular scale. Circular scale. Okay, now you have full idea about linear scale. It's calibrated 0.05 millimeter parts and marked by 5 by 5. Values given by 5 by 5. 0, 5, 10 like this until 25 millimeters. The maximum 25 millimeters. Okay. Okay. Circular scale. Circular scale. Okay, what do you think? How many parts in the circular scale? How many parts? Parts kiyak තියෙනවද? පේන්නේ නැහැ මේකේ values මම. Okay, how many parts? I will show you virtual. How many parts in the circular scale? See this? How many parts?
50 per parts.
How many parts?
50 per parts.
Yes, very good. See? Now 0, right? This is a 0 of the circular scale. Now 5, 10, 15, 20, 25, 30, 35, 40, 45, 45, 46, 47, 48, 49, again 0. The 50th part is 0. Then how many parts? 50 parts. 50 parts. Remember, 50 circular scale parts. 50 circular scale parts. Okay. 50 circular scale part. It is like this. Okay, this is the linear scale and this is the circular scale. Circular scale. 0, 1, 2, 3, 0. This is circular scale 0, 1, 2, 3, 4, 5. 1, 2, 3, 4. It is 45. 45. It's continue 5, 10. Always remember values increasing into upward. In circular scale, values increasing up to upward and it has 50 identical parts. Circular scale has 50 identical parts. 50 identical parts. Very, very important. 50 identical parts. Even parts. With same distance. With same distance. 50 identical parts. See, 45, 46, 47, 48, 49, 50th part again 0. The number of parts 50. It's calibrated up to 50 identical parts. 50 identical parts. Okay, draw this. Sorry. Make you have to name this. This horizontal line is this horizontal line linear scale middle axis. I forgot this. Linear scale middle axis. Linear scale middle axis. Linear scale middle axis. That's a horizontal axis line. That's very important to read measurements. That's why I told. After label this axis, now you can draw this diagram. Okay, if you don't have tubes, please draw in a paper, separate paper. Once you receive tube, you can note down in the tube. No worry. Don't worry. completed, right? හරි. Okay, this is a circular scale. After that, if you want, this is a thimble. This is a thimble, and finally thimble head. Thimble head. Done. Okay. Now we are moving to our next very important part. What is the meaning of the screw gap of the micrometer screw gauge? The screw gap of the micrometer screw gauge. What do you think? What's the meaning of the screw gap? Screw gap, as well as we call as pitch of the screw gauge. Pitch. Pitch කියන්නේ cricket වල pitch එක. No. This is not the pitch in screw gauge. Pitch. Pitch එකක් කියන්නේ මොකක්ද? What's the meaning of the pitch? What's the meaning of a pitch? Okay, now it is a screw nut. It's a screw nut, right? Wait. White. Now this is a screw nut. This is a screw nut. Can you see the screw nut has threads? Okay, threads තියෙනවා පේනවද ඔයාලට? පේනවද මෙහෙම තිබ්බොත්? පේනවා. Can you see these threads? Threads. This is a screw nut with threads. It has threads. If you got the pitch or screw gap of any this screw nail, make a screw nail එකක්නේ. Make a screw gap or pitch mean the gap between two threads. The gap between two threads. If you got this point to this point, the gap between two threads is the pitch. This is a pitch. It is given. This is a pitch. This is a pitch. Gap between two threads. This is a simple pitch or screw gap of this nail. Screw gap of this nail. But in micrometer screw gauge, we can't see any pitch. We can't see any threads, no? We can't see any threads. Okay, then how we can explain? How we can define the screw gap of this micrometer screw gauge? Okay, clearly understand. That's the most important part of the lesson. හොඳට අහගන්න. In micrometer screw gauge, the pitch or screw gap mean. Maybe wait. Okay, understand. It's very slow. Okay. Okay, now see, hari. Okay, now the circular scale 0 perfectly coincide with the linear scale middle axis, right? Vernier scale 0 perfectly coincide with linear scale middle axis. So do you understand? 0 perfectly coincide with linear scale middle axis. Now, now what is the linear scale value here? My value here. What's the linear scale value now? What's the linear scale value? The linear scale value 5, right? Linear scale value 5. මෙතන තියෙන්නේ 5 නේ. Okay, if I rotate this circular scale one complete revolution. One complete revolution means rotate and again come to the 0 coincide. Now how about the linear scale value? Now what is the linear scale value? Now what is the linear scale value? Very good. Others? Now what is the linear scale value? It's 5.5 millimeter. Very, very good. Now this is the screw gap actual. This is a screw gap. I will rotate another one revolution. I will rotate another one revolution. One revolution. One revolution. One complete revolution. Okay. One complete revolution. Another one complete revolution. Now how about the linear scale value? How about the linear scale value? It is 6 millimeter. Very good. 6 millimeter. Now, I think now you have idea what is a screw gap. Actually, then if not, I will explain again. The screw gap of the micrometer screw gap, very good, Nithya. The screw gap 0.5. The screw gap of the micrometer screw gauge is while rotating one complete revolution of circular scale along linear scale, circular scale moving distance. While rotate one complete revolution of circular scale along linear scale, circular scale moving distance. I balan. While rotate. Raise hand. If you understood, while rotate one complete revolution of circular scale along linear scale, circular scale moving distance. Yeah. මේ බලන්න. දැන් හොඳට අහන්න. හරිද? මේක තමයි ඉස්සෙල්ලම තේරුන්නේ නැහැ කිව්වේ. හරි. හරි. මම දන්නවා තේරුන්නේ නැහැ කියලා. හරි. අපි බලමු. හරි. While rotate one complete revolution. One complete revolution I am going to rotate now, okay? Now what is the linear scale reading? Linear scale reading 6. Hurry. Linear scale reading 6. Now if I rotate one complete revolution can now 0 to 0 coincide. 0 coincide to middle axis. One complete revolution mean again 0 coincide to වටයක්ම කරගුණාම ආයෙ එන්න ඕන 0 middle axis එකට. බලන්න. 0 middle axis. Ah, 0 now middle axis. Okay, now what is the linear scale value? It is 5.5. 5.5. Now understand. Now I will read. Now 5.5. What is the previous value? Before rotate one revolution? It is 6. This is the screw gap. While rotate one complete revolution. One complete revolution. අපි දැන් කරකවනේ. One complete revolution along linear scale. This is a linear scale. Along linear scale, circular scale moving distance. ඒ කියන්නේ 6 තිබ්බ එක 5ට ආව එක sorry 5.5 වලට ආව එකක් කරකද්දි. One revolution එක. This is a screw gap. Now okay. wait. I can while rotate one complete revolution. ඒ කියන්නේ complete එක රවුමක් කරකෙද්දි. While rotate one complete revolution of circular scale along linear scale. This is a linear scale. Along linear scale, circular scale moving distance. කොච්චර දුරක් ඒක දිගේ යනවාද කියන එක. Then while rotate one complete revolution. One complete revolution mean instrument එකෙන් බලමු. Now 0 to 0 coincide. මේක නම් values පේන්නේ නැහැ. If I rotate one complete revolution, again 0 coincide. One complete revolution along linear scale, circular scale moving distance. Understood? Priyanka? Jansilu? Great. Okay, for this instrument, for this type instrument, what is the screw gap there? While rotate one complete revolution along linear scale, circular scale moving distance, it is 0.5. And 0.5. 6 tibbekena. While rotate one revolution, it's going to 5.5. Then 6 minus 5.5, 0.5 is the screw gap. 0.5 is the screw gap of normal micrometer screw gauge. 0.5. 0.5. Hard. Okay, this definition is not more clear. Okay, please write down another definition here. Write down while rotate one complete revolution or full revolution of circular scale along linear scale circular scale moving distance. Along linear scale, circular scale moving distance is called as the screw gap. It's called as a screw gap. It's called as a screw gap. In structured paper, several times there was question as define the meaning of screw gap of micrometer screw gauge. This is a definition. This is a full definition. Good. This is a full definition. Several times they have in exam questions, structured questions asked, what is the define the screw gap in micrometer screw gauge? Then how you can write? Why rotate one full complete revolution along linear scale, circular scale moving distance. Linear scale dige, circular scale moving distance. Great. The screw gap is similar word. Pitch is a similar word. Pitch is a similar word. Hari. Now we are moving to most important part. The least count of the micrometer screw gauge. Okay, before that, what's the meaning of the least count of any instrument? I explained earlier. The least count of any measuring instrument, the least count of any instrument, the minimum reading, very good. The minimum reading of any instrument accurately can be obtained. The minimum reading, if you got meter ruler, the least count is 1 millimeter. If you got vernier caliper, normal vernier caliper, it is 0.1 millimeter. Okay, do we remember to calculate the least count of vernier caliper? I gave a equation. To calculate the least count of vernier caliper, I gave an equation. What is the equation? What's the equation? Don't remember? To calculate the least count of vernier caliper, I gave an equation. What is this? මතකනේ? I gave a short form as well. Yes, MSD minus VSD. දැන් මතකනේ? No, Nitira. This is not the equation. Coincide amount multiplied by... No. They are to read the measurement, no? I asked least count equation. Yes, MSD minus VSD. Main scale division minus vernier scale division. Now, yeah. Then last I can imagine what is your working pattern these days. You only come in classes. It's not the method for A level. You can't do A level like this. Okay, as I explained at the first day, starting from first day, I'm explaining this thing. At least you have to get 45-minute study period for every day. If not, definitely your A level result, if you not start now, definitely your A level result SOC. Not SOC. Very difficult to, if you not start now, it is very difficult to go more than 75 marks. Make a lot very difficult. Very difficult to go because every day adding new thing. Okay, therefore, please start today this. If you're still not doing, please start today. At least 45 minutes every day, you have to get one subject. This time, made ourselves at the basic level. No, Rukshan. So, Verdi. Okay, the thing you're not following this method. Hari, kamak na still you starting A levels. No? Okay, now you have start now today. Today you have to get 45 minutes self-study time. This is very important. If you go to more than 3 to 5 classes for one subject, it is useless if you're not doing 45 minutes, at least 45 minutes self-study time. Okay, what you need to do if you need good result, I will give you a speech of our island based result. You can ask him. You can ask him how if you he did his maximum. He spent maximum time for A level, but to A and B, but English medium based result, he have a lot of opportunities. But understand the difficult toughness of the A level. It is not a simple thing like O level. Hari, O level langin tiyandawath bෑ. I know still you can't understand the difference, but now this is the time start. If you need a good result, good island rank, good Z value, this is a method. Every day you have to at least 45 minutes, 1 hour period you have to spend self studies. You have to get self studies. Again, self studies mean again revise what we discussed during the class time. Okay, today start karnawada. I start today. Hari, adava patan ganna. Because if you not start today, lot of students in your batch, it will start today or before today. Then you will be lost in this competition. It's a huge competition. This is the most competitive exam in the Sri Lanka. No any other exams this much competitive. Okay, therefore, please start today itself. Another thing, if anyone interested doing technology stream in English medium, you can introduce our class, because a lot of classes not covering syllabus way, and you can see our 2026 revisions. We are doing perfect revision program as well, and after this each and every lessons we are doing papers of each unit papers, and you will have exam as well, or exam after each unit. Now 2027 class, 2026 class, you can ask from these students, our students, what's the difference. Okay, if anyone need a best result in all island, you can introduce our class. Please send our details. If any your friend doing technology stream. Hari, compilation. You have to do this, okay? You have to get at least 45 minutes per day time for your self studies. Hari. Hari, then mataka neda me tute ke tiyenawa. The least count of the vernier caliper. The least count of the vernier caliper. See, the least count of the vernier caliper. Maybe the least count of the vernier caliper. What is the equation? MSD minus VSD. MSD minus VSD. Main scale division minus vernier scale division. MSD minus VSD. Short form. Hari. I am the going to you have to revise again and complete everything before next week. Before next week. Hari. Okay, now we are moving to the least count of the micrometer screw gauge. Least count of micrometer screw gauge. Hari. Now, it is very simple. Micrometer screw gauge also, we have very simple equation. The least count of micrometer screw gauge equal, the least count of micrometer screw gauge equal screw gap or pitch or screw gap divided by number of circular scale parts. Now we already know what is a pitch or screw gap divided by number of circular scale parts. Hari. Now tell me this instrument, what is a screw gap? What's the screw gap? What's the screw gap? Quickly. This instrument, what's the screw gap? 0.5 millimeter. Very good. 0.5 millimeter. Divide by how many circular scale parts? How many circular scale parts? 50. Very good. Then what is the least count of this instrument? 0.5 over 50. It is 0.01 millimeter. Did you see? I have sent a calculator list into a group. Yeah, all of these versions you can use in exam, during exam. මම දාලා තියෙනවා මෙන්න මේ list එක. Yeah, this any calculator you can use in exam. Better to use this second one is better. It's only 3000. ඒ කියන්නේ මේවා දැම්මම ගන්න ඕනෙත් නැහැ. The calculator first required for our fourth lesson, our third lesson එකට තමයි ඕන. This FX 991 ES second edition good. EX also first edition එකත් හොඳයි. Don't get this MS1. MS1 little bit complicated. This final one, MS, එකත් use කරන්න පුළුවන්, but it will be little bit complicated. මේ ES එක හොඳයි. ES එකක් ගන්න. ES or EX එකක් ගන්න. හරි. Okay. We have another 5 minutes. Hurry. Write down a question. That was an exam question. Metaning hurry book ke hurry anda. That was an exam question. That was an exam question. There is a micrometer screw gauge. There is a micrometer screw gauge. There is a micrometer screw gauge with 50 circular scale parts. With 50 circular scale part. There is micrometer screw gauge. There is a micrometer screw gauge with 50 circular scale parts. With 50 circular scale parts. 50 circular scale parts. 50 circular scale parts. 50 circular scale parts. While rotating, circular scale five revolutions, while rotating circular scale 5 revolutions along linear scale, circular scale moving distance, 5 millimeter. හරියට ලියා ගන්න. While rotating circular scale 5 revolutions along linear scale, circular scale moving distance 5 millimeter. Calculate the least count of this instrument. calculate the least count of this instrument. Okay, that was the exam MCQ question. Hari. ගන්න බලන්න. Now, Shiva, you have to again read this question. Again, read question. No, Hashini. Please read again carefully. පරිස්සමට කියවන්න. Yeah, Nitira correct. Good. Carefully read and substitute to the equation. Okay, what is the equation? Least count equal screw gap divided by number of circular scale parts. Number of circular scale parts. Now, Rukshana, row. Again, read the carefully. Hasandu. Okay, tell me how many circular scale parts? How many circular scale parts? And Shivan, 5 circular scale parts? No, Kalindu.
50.
50. Circular scale parts, 50. Now correct, Hashin. Yeah, it is 50. Circular scale part, 50. Next. Sorry, circular scale part 50 again. Circular scale part 50. Now what is a screw gap? That is a problem. What's a screw gap? What's a screw gap? That's a problem. Screw gap here. Very good, Hashini. It is 1 millimeter. Yes. How to get? While rotate 5 revolutions and while rotate 5 revolutions, the circular scale moving 5 millimeters. Then what is the actual screw gap? While rotate 1 revolution, circular scale moving distance. Within 5 revolutions, the moving distance 5 millimeter. Then within 1 revolution, how about the moving distance? 1 millimeter. 5 divided by 5. Teruna? Shema? Akil? That was exam question. Yes, the screw gap mean within one revolution, within one complete revolution along linear scale, circular scale moving distance. Now this question given within 5 revolution, 5 millimeters is moving. 5 millimeters move in 5 revolution. One revolution 5 divided by 5 millimeter. Sorry, 5 millimeter divided by 5, it is 1 millimeter. Now 1 divided by 50, it is 2 divided by 100. Both. Then 0.02 millimeter. 0.02 millimeter. 0.02 millimeter. Okay. Do you have any doubt up to now? Any kind of doubt, parts or any function or any make a measuring mechanism or any doubt? Okay. The first part of the micrometer screw gauge part is done. Last part. Last part means screw gap part, right? Okay. Screw gap part. Yeah, calculation part. Hurry. Yeah, this is a method. Now, any micrometer screw gauge, how to calculate the least count using this basic equation, screw gap divided by the number of circular scale parts. If you got common one, it's screw gap 0.5 millimeter divided by 50, it is 0.01. That's okay. Hurry. Metana dahoy in the calculation. This point. It's a short method, just a trick. I multiply both values by 2. 1 divided by 2, it is 2. 50 divided by 2, it is 100. Then we can get the value without calculator. Then 1 divided by 50, 0.02. 2 divided by 100, it is 0.02. It's a short method. Then trick එකක් මම දෙකම multiply කරා 100 වලින්. එතකොට 1 multiplied by 2, 2. 50 multiplied by 2, 100. Then 2 over 100 without calculator we can get 0.02. එතකොට මේකේ answer එකත් 0.02. Clear? Okay, if you have any, do you have any doubt about this screw gap calculation? Screw gap mean while rotate 1 complete revolution, moving distance, circular scale moving distance. If it is within 5 revolutions, if it is moving 5 millimeters, then 5 millimeter divided by 5, this is a 1 revolution distance. It is 1 millimeter. Okay? Okay. Okay. What else? Other doubts? Her. Yeah, which question? Final question. Okay. Now this question given, number of circular scale parts, it's already given directly. 50, right? Question given, number of circular scale parts, 50. Okay, it is given as 50. And while rotate 5 revolutions of circular scale along linear scale, circular scale moving distance 5 millimeter. 5 millimeter. Okay. Now, first you need to understand perfectly what is the meaning of screw gap. While rotate one complete revolution of circular scale along linear scale, circular scale moving distance is a screw gap within one revolution. But the question given within 5 revolutions. Within 5 revolutions, 5 millimeters moving. Now, how to calculate screw gap? Screw gap. Screw gap. Now moving distance 5 millimeter. 5 millimeter. Within 5 revolutions. What's the meaning of screw gap? Screw gap means within one revolution. One revolution. Then we can divide by 5. Then 5 to 5 cancel out. It is 1 millimeter. Now I just substitute 1 millimeter into this equation. Vinuji, okay? Hari. Okay. Okay. Homework. Write down a question. Write down a homework question. Write down in your book. There is a micrometer screw gauge. There is a micrometer screw gauge. With 100 circular scale parts. 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 While rotate 5 revolutions of circular scale, while rotate 5 revolutions of circular scale, while rotate 5 revolutions of circular scale along linear scale, circular scale moving distance, circular scale moving distance 2.5 millimeter, 2.5 millimeter along linear scale, circular scale moving distance is 2.5 millimeter, is 2.5 millimeter. Calculate the least count of instrument. Calculate the least count of instrument. Hari. This is a homework question. This is a homework question, and please practice and go through again and again several times before next class. Hari, then godak tiyena. That's why I told. Then make karapu nathi ayata then godak tiyena. Now you have 2 instruments to revise again. If you already complete vernier caliper, you have very small parts. That's why I told you. That's why I told. Hari. However, get at least 45 minutes self-study time and work very well before next week. Complete everything and revise several times. May parts එහෙම නැත්නම් next week වෙද්දී you will forget. Normally our brain is designed to forget unnecessary things. අපිට ඒ කියන්නේ ඔක්කොම මතක තිබ්බොත් ඒක නිකන් අර පිස්සු වගේ වෙනවනේ. Therefore our brain is always designed to forget unnecessary things. Forget unnecessary things. Okay, therefore, you have to careful make sure in our brain with these study materials, study things, required things. Required things කියලා signal එක දෙන්න ඕනේ. How you can give this signal? කොහොමද ඒක දෙන්න පුළුවන්? You have to revise again and again. ඒ කියන්නේ ඔයාලා මතක් කරන දේවල් විතරයි අපේ brain එකේ තියාගන්න. Other all unnecessary things. If you not revise again and again, the our brain always thinks these are unnecessary things. ඒතකොට එයා මොකද කරන්නේ? delete කරලා දානවා. It's same as our mobile phone. ඔයාලා බලුවොත් ඔයාලගේ storage එකේ ඔයාලා frequently use files තමයි උඩටම තියෙන්නේ. අනිත් ඒවා යට තියෙන්නේ. හොයාගන්නත් අමාරුයි. Our brain is always ඒක තමයි. That's the nature. That's the nature. The forgetting is the nature. But if you need ambition or if you have a target, you have to revise again and again. It's a little bit tough work. Initially, it is tough work, but if you practice, it is very easy. Yes, you have sent answers. You are correct. Hi. Answers. Answer එකත් මම දෙන්නද? හරි. Answer එකත් දෙන්න. Okay, now while rotate 5 revolutions, the moving distance only 2.5 millimeter. Then what is a screw gap? What is a screw gap? 0.5 millimeter, because 2.5 divided by 5, it is half. 1 over 2, that means 0.5 millimeter. Now 0.5 screw gap 0.5 least count equal screw gap divided by number of circular scale parts. Screw gap 0.5 divided by number of circular scale part 100. 100. Number of circular scale part 100. Then what is the reading? What's that? Not reading, least count. 0.005 millimeter. 0.005 millimeter. Vinuji understood? Yes. Great. Okay, now you can practice. Next week, very important. I will explain next week, the first 1 hour of the next week class, I will explain how to read measurements using micrometer screw gauge. Anyone don't miss this part. It is the most important part of the lesson. How to read measurement. Then අපි දන්නවා දැන් measurement එක ගන්න steps. We have to place close to the anvil and rotate by thimble, final part rotate by thimble head and tight into required level. Up to now you already know, but still you don't know how to read this measurement. Okay, that we can discuss next week class, as well as the micrometer screw gauge errors. What are the errors of micrometer screw gauge? 0 errors also we can discuss in the next week class. This is the final part of the micrometer screw gauge. Okay. Again, do you have any doubt? Then Then let's meet next week. Sorry, wait. Next week have a problem. Wait 1 minute. Yeah, I'll inform in the group. කවුරු හරි group එකේ නැත්නම් ඉක්මනට add වෙන්න. If anyone not in our group, please inform me. You all in the group, right? Our main community group. කවුද නැත්තේ? All in our group, right? Hari. Okay, I will inform 12. I have problem because 13 UVN. 12, I think I have to go. I will let in the group. Yeah, community එකේ ඉන්නව නම් ඇති පුතා. මම ඇඩ් කරන්න අනිත් ඒවා. Community එකට එන්න. Okay, we have to get an extra day. I will inform. 12 is New Year break, vacation time. 19 you have class. 12 class I will inform what we can do for 12th class. Okay, I will inform in the group. Keep attention with group announcement. Okay, goodbye, good night.